Welcome, everybody, to today's episode of Incubator Weekly. Today, I have on the show Matt Peterson. How's it going, Matt?
Going good.
Good. Nobody in the Dash community has probably seen you except for potentially AJ for sure, because that's how we got to know you. Today, the title of the show today is, let me just check, just make sure. It's Decoding Platform, Rust to JavaScript. And that's kind of like a little bit of a play on words, kind of literal, kind of not literal. Decoding platform is something that we are trying to do in the general sense of like what's actually going on in platform, but also in the literal sense of decoding bytes and things like that and encoding. That's part of the reason that we brought you on, Matt. So I'm going to go ahead and share my screen to set up the purpose for what you're doing, and then we'll talk a little bit about who you are. So just a little bit of background. We in the Incubator are trying to build a lightweight library to talk with Dash platform. Once again, just as an overview with the work that we've done in my corner of the Incubator, we have been putting that in this Dash Hive repository. It's mostly work that AJ has done, and mostly up until this point, we've been dealing with layer one, or actually, I'm not sure if I love the term layers. I'm kind of in Joel's camp on this. I'll just say the core blockchain, which is a proof of work blockchain. Most of the work has been interfacing and having libraries that interface with that core payments technology of Dash. But we're also trying to get a library to interact with Dash platform itself, which is a separate blockchain. And I'm kind of explaining this both to the audience, but also to you, Matt, because you're not super familiar with Dash. We've brought you in as a ringer to do a specific thing that AJ was having some trouble with. And I'll talk about that in a little bit more in detail. But still, in overview land, Dash platform is a separate blockchain, but run by the same nodes, or at least a subset of the nodes that run the core blockchain, run a separate blockchain that is a proof of stake blockchain. And they use those nodes that are running this proof of stake blockchain are called Evo nodes, and they run additional services in addition to the core blockchain. They're running what are so-called platform services like DAPI, DAPI, the Dash API, or the decentralized API, whatever you want to call it. That's one. And then Dash Drive is another one. And basically what it is it gives the opportunity for developers to store data, structured data, on these Dash platform nodes, and that all come to distributed consensus and sync up the state of that blockchain in terms of data and not just payment state, which is what the core blockchain does. Is it's doing something similar, but just for payments alone. And this is general purpose data storage. And we'll talk a little bit more about that as well. But part of Dash platform is that the serialization, the service, the DAPI service is a gRPC service, and we needed somebody to be able to encode and decode messages for gRPC. And so that's the high level of what AJ was trying to do. It's a lot of that is based on the Rust code base, and AJ is not a Rust developer, so he typed in a message to the Rust meetup, which I'll share a little bit about here, and I'll ask you to talk a little bit about. Utah has quite a few meetups in general, and one of those meetups is the Rust meetup. And so AJ popped in and said, "Hey, I'm having some trouble with figuring out some encoding and decoding stuff in a Rust code base that I'd like some help on. Can you tell us a little bit about that message that AJ sent to you and what he was asking you to do?" And the short, like the end result is that you were able to do that, and we're going to talk about that later in the show, what you did, and that you got some tests passing that he set up. But first of all, just give us an introduction to yourself, Matt. Who are you, and what are you doing in the Rust meetup? What's your interest in Rust? And yeah, just tell us about yourself.
All right. So yeah, my name is Matt. I've been a software engineer for something like 15 years now. Um, and I have been going to the Utah Rust meetup for a little while, which AJ actually used to like run the thing, which I think is kind of funny that he was running the Utah Rust meetup and not actually being a Rust developer.
Yep.
He is now running the Zig meetup, which is like right next door. Um, uh, but anyway, um,
Yeah, he likes
so
to get
that's
meetups going. He's more of like a social guy. He just likes he likes to look
yeah.
into all the different programming languages, and so he just organized this. I recognize this clean cut guy
Hmm.
because way back like 3 or 4 years ago, Dash was actually trying to figure out. Okay, originally platform was written in JavaScript on the back end,
Hmm.
and because there was a lot of rage back then, like good kind of rage, like it's all the rage. There's probably a
Hmm.
lot of rage in the bad sense now for JavaScript on the back end. But long story short, we started it in JavaScript, and then we were going to start rewriting it in either Go or Rust. And so we were looking into these. That's when I started looking into Rust personally, and I joined the meetup. Then I talked with this event organizer, Clean Cut. What's his real name? His
I
anyway,
don't
he
even remember. He's got
he
a pretty well-known Rust Udemy, I think Udemy course.
yes,
Um, so and
he's
he
one of
does some
the
like
more.
beginner game dev and Rust kind of things. He does a lot of that.
Yeah, so chances are several people in Dash that might have taken his course, because I got him to give me access to, like preview access to a course that he was making at the time, like on Rust, and I shared a link to it, and so several people might have taken that course. That's this guy right here. And then yeah, it looks like the meetup has like 500 plus members now, and you're one of those guys. So yeah,
Yep.
continue on with your story. Sorry, I cut you off.
No, that's all right. So anyway, I met AJ because I went to the meetup several times. Um, and I've even popped into the Zig meetup a couple of times too, because um, the Rust meetup in the beginning there was a little bit of more advanced things in there, but it seems to be moving a little bit more towards beginners now, mostly towards just the people that are actually showing up. There seems to be a lot of Rust beginners that are also interested in like either beginning embedded things or beginning game development. So that seems to be where a lot of the interest is now. Um, but yeah, I'm interested in programming languages a lot too. I like picking up new languages when they come up. So of course, when Rust showed up on the scene, I was very excited about that and using it a lot. Um, Unfortunately, only in personal projects. I still have yet to really be able to work on a Rust project for work, other than Dash now, except that I'm still not actually working on the Rust code. But
Yeah.
anyway, um, yeah,
Halawi
it's
does say yes, I took the course. Thank you. So that's cool.
yeah.
Um, yeah, so let's jump into what you
All
were
right,
working on. Unless you wanted to
sure.
say anything more about your background, what your interests are. Actually, I did want to ask you specifically. We talked a little bit. I'm getting to know you right now, and I figured why not just open it up to the Incubator audience in general. But yeah, I would like to know what your overall interest and experience is with cryptocurrency in general.
Right. Yeah. So I was fairly early on in the Bitcoin investor game. I did not have a ton of cash at the time. I was pretty young, but I did invest in Bitcoin when it was around $400. Was the first time I ever invested. I then subsequently made a series of really stupid trading decisions and ended up losing most of it. So I'm not I'm not particularly wealthy for it. I did make a small amount of cash off of it that went into house down payments mostly, but nothing too extreme. But I've been in the interest in Bitcoin for uh, most of its lifetime. Um, but I haven't actually done a lot in like the code, strangely enough. I
Hmm.
never really had much of an opportunity to actually work on anything. Like I never got into any of the crypto startups or anything like that. Um, so anyway, I've had some kind of I've had my eye on crypto for a while. I've read a lot about it, but I actually haven't done a lot of actual coding in that space.
Yeah, well,
Yeah,
most of the code bases, Bitcoin itself is a C++ code base. That's the
right.
reference for that most people use. Dash itself is a fork of Bitcoin, and so our main client, I don't know, it kind of bothers me that we call them clients, but people do. They're more like servers.
Yeah,
Most of the reference implementation of the node, a node is probably even a better term because it's both a client and the server, honestly.
yeah.
Uh, but yeah, that's in C++ as well. But because we have this new project that is a completely new blockchain that does have a native bridge between the two blockchains, between our core C++ proof of work chain and our platform Rust primarily proof of stake blockchain, although there is a strong component that's written in Go. The actual consensus mechanism is written in Go, but platform is written mostly in Rust. So there's all
Right.
sorts of, if you're a JavaScript developer, if you're a Go developer, if you're a Rust developer, if you're a C++ developer, we've even got Python and all sorts of like Swift and Kotlin, and we've got it all. So pretty much anybody who's interested in and has experience with any language can do something in Dash, and that's one of my main roles that I'm trying to take on is trying to get developers to take a look at Dash, see what we're doing, and see why it's interesting. Just a brief comment on Dash versus Bitcoin, since you have a little bit of background with Bitcoin. Dash is essentially trying to take the torch that Satoshi Nakamoto, the creator of Bitcoin himself, started. It was originally intended to be for payments. Appear like the title of the white paper was peer-to-peer electronic cash or peer-to-peer digital cash, to use a different word. The word Dash itself comes from, it's a portmanteau of digital and cash, Dash. And so we are continuing that vision of peer-to-peer payments and not just trying to use it as a speculative asset that hopefully will go up and give you more fiat currency after you sell it. So we're trying to
Which I can
create a
tell
real,
you doesn't work unless you're really, really, really good at trading, and you're not.
yeah,
So
yeah. Most people are going to
I'm
lose
not.
that game. Yeah, because most of us don't have as much information as the big whales. Um, but yeah, like we want this to be actually a currency that's traded peer to peer and has low fees and is very fast and very secure. Those kind of things. So that's still our vision. It seems like Bitcoin has given up on that and is mostly just trying to. They don't mind that the fees are high. They don't mind that people don't actually use it. It's actually considered a virtue to just buy it and hold it and not actually use it. Dash is different than that.
Yeah.
Especially with Dash platform, we're trying to target another use case, which is developers. If they have an application specifically where data is considered public, um, and they want to open that data up to anybody to draw from that data, to build on that data, to add to that data, to pull that data into their applications in a permissionless way. That's what Dash Platform is. And let's go ahead and get your screen share started now that we've got some background, and I've given you a little high level on Dash, what Dash Platform is. Let's get a little closer to what you're working on. And while you're getting that going, I will also just give a little bit more background about what we're trying to accomplish here. So the way that people interact with Dash Platform is primarily with initially with mobile applications. Our Swift iOS app and our Android apps, they have code bases that import WASM bindings, and that's what our JavaScript library does as well. We have a dash on npm dash, that library. If you look on that library, that's what we're using. That has WASM bindings as well. But I think JavaScript is particularly important because it gives access to web developers, and there are way more web developers and web applications than both desktop and mobile application developers. And so I think that JavaScript deserves to have a native protocol that is calling into Dash Platform and not needing WASM bindings. For one reason, because it will be a lot more performant in terms of both bandwidth and download size, things like that, but also just speed of interacting and doing transactions with Dash Platform. So that's why I have AJ working on this JavaScript library that would natively talking to Dash Platform, specifically natively talking to the nodes that are running the gRPC service on the platform Evo nodes. And so he was having some trouble with the encoding and decoding of messages that are gRPC messages. So I'll pass it back to you now.
Yeah, let me see if I can add a little to that. So, and I also want to mention, by the way, that I learned about Dash for the first time about a week ago when I got put onto this project, when AJ put out a call for help in the Utah Rust Discord. So a lot of this is going to be based on my very limited understanding of what I did just to try to get this part done. So I could be wrong at any point here. My understanding is that there is a gRPC layer that is like the first layer that the nodes interact with. And then almost as soon as the gRPC message gets decoded, it seems like the only thing inside is just a pile of bytes. Like it's just using a byte array as the internals of the message. And then everything inside of that gRPC message is then encoded in a different way. And it seems like either the spec is out of date or maybe just not easy to read. But there was some understanding that the encoding of the messages on the inside was either JSON or CBOR or something along those lines, and not very obviously understandable, at least by AJ.
My understanding of that is that, yeah, the spec isn't really documented yet. The implementation is the spec at this point, and the implementation is Rust. And so, yeah, that's why, like, you understanding Rust can look at everything's open source, right? So we can look at the Rust code base, and actually Sam Westrich, Quantum Explorer, he gave us some of the raw bytes that we're passing across over the wire. I don't know if you actually looked into that branch of the Rust code base where he put some logs to log that out.
I did. In fact, I added my own too.
You added some. Okay, so you got that Rust code base going, built, added some of your own debugging statements. So
Yep.
I'm trying to get you up to the point where obviously you're not going to understand in 1 week what Quantum Explorer Sam, CTO of Dash Core Group, has been working on for years. But at least you could get the code base up and running and put some log statements in and just kind of tinker around with things and see how reverse engineer how it's working. Because right now, like I don't want to bother Dash Core Group with things if I don't have to. And so that's why it's good to have you as a Rust developer knowing the tooling, because it's not just knowing the language, it's knowing all the tooling and being able to get
Right.
that stuff up and going that we
Well,
need.
and even Rust has many layers to it, which in this case, the layers is what made it really difficult to understand how the encoding was working. Um,
Tell us more
because
about that.
so yeah, so I've got, for example, one of the identity create transition structs in here, and this enum is a version enum, so the actual data inside is marked under this version 0 so that they can like add a new version if they need to evolve the layout of this struct or whatever information is inside it. Um, so um, this is basically all you get when it comes to like how is this serialized. There's all of these extra annotations on there. Um, Specifically all of these that end up deriving, like creating new code based on all of the rest of this.
Mm.
Um, so for somebody who is not a seasoned Rust developer, this could be quite confusing and overwhelming to see that like there's areas of the code that just calls a signable bytes method on this struct, and that function doesn't seem to exist. So it can be kind of confusing as to where this is coming from.
Can you bump up your font just a little bit, because I think that we're streaming in kind of low quality,
Sure.
so it probably will help to bump it up a bit.
Yeah. Is
So
that good, do you think?
yeah, so for a JavaScript
Okay.
developer, these hash things could be considered kind of like decorators in
Yeah.
TypeScript. Is that right?
Yeah. Pretty similar.
Okay, so they essentially do additional things um, with the actual functions and code below it.
Right. Now, and the thing that gets interesting here is that this would even be a little bit confusing for a normal Rust developer because um, it seems that they have not been happy with the standard Serde serialize and deserialize macros that people use in Rust. Um, and it seems to be because they wanted an easy way of encoding in a couple of different formats or a couple of different like uh, ways of encoding the same message. So, for example, the way that I'm going to point out this is in the identity create transition um, message or struct, I don't know what you want to call this, there is a marker in here that says exclude from the signature hash. So when you generate a signable version of this, um, it is going to run through the normal serialization code, except it's going to skip these two fields, which I gathered mostly just from reading the code and a little bit of intuition here, and then verifying it in the actual testing of the JavaScript code. But this is something that is not part of the normal Rust ecosystem. So,
So when you say
yeah,
the term that you've used a couple times is Saturday, it's at the bottom right of
Saturday.
the screen. That stands for serialize, deserialize,
Yep.
and that's
So
like a
that
standard
is
Rust thing.
right. So Rust has a split between the the ability to serialize and deserialize a struct and the actual encoding that it is serialized into. Um, So like, for example, you often want to have a struct that can be serialized in multiple formats. So you might be able to want to serialize it into JSON and XML and like CBOR or BSON or various different other kinds of encodings. And in Rust, you have to use code generation for this. There's no way of just like reading out the list of fields and then just doing something like you can in Go or JavaScript. In Rust, the only way to get the list of fields is by using one of these derive macros or some other sort of code generating macro. Um, and so you don't want to have a different macro for encode and decode JSON, encode and decode XML, encode and decode CBOR, encode and decode BSON, and all of the other different formats that you might want to use. And so they have Serde, which is a kind of a generic serialize, deserialize that is encoding agnostic. So what it does is it expects a serializer when you pass when you call the serialize function, and the serialize function just tells the serializer, hey, I have a field. Can you serialize this field however you want? And then here's the next field, and serialize that however you want. And
Just
then the
real quick.
serializer is like the bin code version or the JSON version, and it handles the actual like conversion to bytes.
Okay, just real quick. I know a lot of developers will know these terms, but for the semi-technical or non-technical people, can you give an explanation of just what it means, what serialization means, what encoding means, just so that everybody can kind of have a rough idea of what you're talking about?
Yeah, sure. So when you have this struct here, um, the general expectation is that the compiler will know where all of these things are. But other than that, there's no guarantee of what the actual real layout is in memory, or at least there's not a guarantee at this level. And there's no, in particular, there's no guarantee that the representation of the struct in memory will be the same between any two machines,
Mm-hmm.
or any two versions of the same code. And so the serializing and deserializing is a way of converting this possibly unknown in-memory representation to some specific sequence of bytes that can be read and understood by any machine, by any version of the code, that can be easily transmitted across the network. This struct stuff can also include like things like pointers that are only valid for the one instance of it in memory right now, so you can't even send that over the network. So yeah, the general idea of serializing is I have some information, let's put it into a known format so that it can be transmitted to some other machine, some other piece of code somewhere else.
Okay. And the encoding and decoding, how is that different, or what's that part?
Yeah, so encoding is there are just lots of different ways that could be represented. Um, so JSON is a common one that is fairly verbose and easy to use by lots of tools. It's JavaScript's kind of default representation. Um, but when it comes to Rust or when it comes to transmitting things over the network, JSON is very kind of verbose. It takes a lot more space than it really needs to.
Mhm.
Um, and so here in this code base, for example, they've opted to use bin code, which is a fairly straightforward way of just like just write it down in the most concise byte format that you could possibly use. Um, and that means that their messages take up a lot less space, which is especially important for these cryptocurrency nodes when they're passing these messages back and forth, when they have to do a lot of cryptographic hashing to verify that things are correct. You don't want to have a large amount of bytes that they have to hash because that's just a lot of extra work. And so there's a lot of emphasis in wanting to shrink the number of bytes down that they have to care about to as small as is reasonable um, to make the work on these nodes as low as possible and the storage requirements as low as reasonable.
Right. And as far as I can understand, there's the only downside to that might be that it's not as it's not documented as explicitly because you kind of have to know, okay, what was omitted, what's included, what order are these in, and so
Right.
it's less self-documented, and so that's why it can be difficult if you don't already know some data that is actually passing and fulfilling the required specification. um, then it's hard to tell how to re-implement this in another language, for example. And
Exactly.
that's the challenge. And I guess maybe we could move into that if you're ready. What we're trying
Sure.
to do is we did get from Sam, okay, and from that logging and the extra logging that you did, we know what bytes are going across the wire, and so we can kind of recreate. We can have a test fixture that says we know that this works in the Rust that was created by the Rust code base. Now let's create a JavaScript code base that does the same thing and see if it passes the same test. So do you want to walk us through that?
Sure. So, um, so the description that I was given is essentially we need to be able to encode state transitions to be able to transmit them to other nodes, possibly decoding them as well. Bin code being something that was invented for the Rust ecosystem. There are like hints of other people using it in JavaScript, but doesn't seem to be any standard way of doing it, especially since um, as I mentioned before, bin code is very concise, and one of the ways that it's very concise is it does not include any self-identifying information inside it at all. So, for example, you can open up anything in JSON encoding, and it has like field names and it has braces to delimit where objects start and end. Bin code has none of that. It doesn't tell you what you should be expecting next. It doesn't tell you what field you're at. It doesn't tell you what struct you're looking at. You just expected to know what you're decoding already.
Mm-hmm.
And so I had to translate all of these struct encodings into JavaScript because that is the like how you decode and encode with bin code. So I wrote a few foundation bits, which is mostly the core, like how you encode the basic integers and bytes. Um, so I have this quick little helper class that is, it's essentially a little bit of helpers to help you stream data into and out of a data view, which normally can't be appended to. So I have a little bit of stuff for that. And then I have a bunch of infrastructure that tries to create an object that has encode and decode implementations bundled together, which acts a little bit like a type, um, because then I can write down a struct definition. Let me see if I can find this exact one. So we have the signable version and the signed version, as I was talking about before, that has the signatures as part of it. The signable version that does not. And so we can see here that there's this magic version constant, which pops up as part of, I think it's actually built into the platform signable code. Or no, sorry, it's part of the enum. But you can see here that I've just translated. So this was literally a copy and paste and then a little bit of editing, where I copied this into here, and then there's this struct constructor that creates the code to encode and decode the struct based on this definition. And I'm getting lost in my own thoughts here. And the enum that wraps it, which is the version without the v0 over here. Yeah, so does that make any sense? Should I go into more detail here, how this works?
I think maybe maybe we could jump to like quote unquote cut to the chase, not because the details aren't important, but just to
Sure.
show people where it's going. You wrote a test, right? A test file.
Yes.
Let's talk about that and then we can dig into details from that launching point.
Right.
Start from the end, so to speak, of like what you were given as this is truth, and how can we test that the JavaScript code is producing the truth.
All right. So this is a minor modification of the the test that was created. The test they were calling it a test fixture, but that's not actually what I would call this. But anyway, just the test of like, can we encode the same message? Can we sign it the same way and produce the exact same bytes as the official REST implementation?
Mm-hmm.
So the official REST implementation has this nice test, which tests how encoding and decoding and signing of the create transition message works. And as part of that, they added these print statements for us where they generated the signable bytes of the state transition and then hex encoded them and printed them out.
Now, is that part of that special branch that Sam wrote, or
Yes.
did you write this? Okay, I see the blue. I see the little blue. That means this
I
is a diff.
believe that is just formatting. I believe that I ran the formatter or something, and it just changed the order of it just changed the white space a little bit.
Yeah. Anyway.
But anyway, this is the test to show how state transition serializing and signing and all that works. And so this can be run pretty easily just by running the Rust tests. And then you just turn off the capture so that you can actually see the standard output. And then I just copied those bytes from that test fixture and a few of them from my own runs of this over here. And some of the messages also can generate a like canonical JSON encoding, which I'm not entirely sure what that's used for, but maybe it's used for communication because this is part of the WASM bindings, or it's used in the WASM bindings. So anyway, I have the bytes of an actual, actually I should go down to the bottom here. So I have the bytes of an actual state transition here as generated by the Rust code. And then we test whether it can be encoded, whether we can, sorry, first whether we can decode it into a valid JavaScript object, and then whether we can then re-encode it back to exactly the same bytes to test that the encoding and decoding is working correctly. And there are other cases too where I don't have it in this case because it seems that state transitions don't have the JSON code in Rust, but there are places where like these identity public keys do have a specified JSON encoding. And so in those cases, I have the actual JSON encoding pasted in here as well. And we tested that with some minor tweaking that we get the exact same JSON out of the decoding process as the Rust code also generates to prove that we're doing it exactly the same way.
Okay, well, should we run the test and see it work?
Sure. So I actually have it running here in as Vitest here. So it runs automatically when I save the code. But you can see here that we've got all three of those passing.
Okay, so the first test is it should encode and decode the identity public key.
Yep.
Then it should encode and decode the identifier, and it should encode and decode the state transition. Now, I don't know if those mean much to you, but the main goal that I had AJ working on was with this overall integration of trying to get a native JavaScript library that can talk with a platform node and do platform stuff. The first and only thing that we were focusing on was the identity create transition or transaction. Transition is just a term that is used for like an instruction to one of these Evo nodes that ask it to change the state of platform. And identity, creating an identity is the first thing that you need to do on Dash platform, because that's what allows you to pay for things, and interact with Dash platform. So that's like the first thing. The other things, and this is just for you, Matt, and anybody else who's interested, the main things that you do on Dash platform is creating a so-called data contract. And what that is it's basically just a data schema. Let's say you're creating an application that is a note-taking application, and you want all notes to have a title, a description, and an author. And so you would create a data contract, which is like a typical, like if you were dealing with Mongo, you'd have a schema that the database is supposed to adhere to. That we call that a data contract in the Dash world. And then there are documents that adhere to that data contract. So title, go buy some eggs. Description, do it at this store. Author, Ryan. And that's a so-called document. And so the main components of working with Dash platform are your identity, which is the authorization kind of layer, and payment layer. So identities, data contracts, and documents. And so yeah, we're focusing just on that identity part right now, and it involves identities are essentially a list, a set of public-private key pairs that allow you to do stuff. And so that's what those are all about. And then the state transition itself is the instruction to do this, like create the identity, for example. Okay, so yeah, keep going. I think we've been going for about 40 minutes, so we can wrap up at some point. But what else about this project did you want to talk about? Can you talk about what part was interesting, challenging, steps going forward? What do you say?
Sure. So, I mean, I guess the thing that comes to mind right now is just that, as you said, the focus initially was just on creating an identity. And so, like, I don't have all of the other transition types actually implemented at the moment. So going forward, I'm filling this out, copying all of the other struct definitions here. Something else that's been bothering me a lot is like in the REST code, when they have a part of the message that they don't want to be included in the signature, they just get to add this nice little annotation that says we can just exclude it from the signature version, and then it generates two different versions of the serialization code. The most obvious, straightforward way to do that in JavaScript was just to create a copy of it that uses the signable versions. But then that means that everything that uses them has to also have a copy. So like in this case, we have to have the state transition and the signable version of the state transition, which, you know, copying and pasting just to have like this as the only difference in the entire definition is really not great. So one of the things I've been looking into is possibly adding an option into the encoding to be able to say whether you're encoding in the signable encoding or not. And then I could add a wrapper around some of these where, for example, if we were to go here, I could add a wrapper that's just something like signable only, which would completely ignore encoding and decoding this field if the signable flag was set during encoding and decoding. And that would allow me to not have to have identical copies of the struct in both places. So that's a possible future improvement. Another possible future improvement is some sort of automated mechanism for copying this from Rust, because as of right now, any changes to the Rust code base, such as any added versions, will require manual effort on the JavaScript side to maintain that. So there's a handful of options that could be done there.
Yeah.
But honestly, the manual effort is not too big of a deal. So that is probably good enough to just deal with that for now until somebody wants to take on that.
Yeah, in theory, the protocol shouldn't change until the version, unless the version changed, and I don't expect that to happen too frequently. And so, for this proof of concept, I think it's fine to not overly abstract things and automate things necessarily, especially with the budget that we have to work with, which is pretty much nothing right now. And so, yeah, I think what we'll do from here is AJ will take a look at this, um, and try to finish what he was doing with it. So the overall repository, you've added some commits. You cloned his repo, added some commits to add this test and the bin code, encoding and decoding stuff. So he'll take a look at that, try to get the actual identity working, creating an identity, and then we'll see where to go from there. It looked like you had a list. I don't know if that was a complete list, but it looked like only like 8 or 9 things. Can you scroll back to that list real quickly? Because I saw, yeah, this right here. It looks like this is, if those are the only things, then that's definitely manageable. And now that you've got the overall structure for,
Don't
how.
make the same mistake I did in thinking that that's all, because each of these is a complicated struct with nested structs inside of it, so on and so forth. So there
Okay.
could be a lot of things to add from all of these, but the important part is that the core code is done, and so adding these should be pretty straightforward.
Should be, yeah. Operative keyword, yeah. That's always tricky, but I think this is good progress. Thank you for doing this. I was like very impressed, very surprised to see that you got it working so quickly. And yeah, I hope we can continue to work on this together, and we'll pass it to AJ, see what he thinks. Any last thoughts before we close out the show today?
Nope, I don't think so.
All right. Well, thank you everybody for joining in. Thanks Halawi for posting a little comment there. It's always nice to see. And until next time, we'll see next week. I think next week we're going to have a little bit of a more fun, less low level topic. We've got TX City, which transaction street city. A lot of people remember that from back in the old days. It's a fun little transaction viewer that we have Dash support for now, and are getting some more details, and that those details should be done by next week. So we're going to have the developer come on and talk about that. So join us next week for that. And till then, we'll see you next time.